So, welcome everybody to the not quite live anymore Q&A. You will see this on Friday afternoon when Devoxx Belgium already closed its doors, but I managed to capture Brian. You would not believe what a kind of enormous task this was, but we made it work.
Yeah.
Like, you're obviously very frequently requested by people. And I know everybody knows you, but just in case we had a straggler, why don't you tell us why everybody wants a piece of your time?
So I'm Brian Goetz. I'm the Java language architect. So what that means is that my job is to figure out where's the Java language going and how are we all going to be programming in 5 or 10 years with Java.
Sounds easy enough.
Easy enough, yeah.
Okay, and you gave a bunch of talks here. There was one on Valhalla, which I found really interesting. There was one on serialization that we already talked about, to the inventor of Clang marshalling himself, is how we supposedly call it now.
Yeah.
But then also you gave one part of the keynote, which was about postcards from the peaks of complexity, or peak of complexity singular, I think. And I really like that analogy. I think like you gave a talk that really tried to tell people about not how you designed a specific thing, but how to design things. Mm-hmm. So, what are the postcards? What is the peak of complexity? What's all that? Give us a little bit of a rundown.
Yeah. So we've done a lot of large projects in the history of Java. We added generics, we added lambdas, we added modules, we added pattern matching. And these projects are like decade-scale projects, which is really kind of mind-blowing for a lot of developers who might work on a feature for a few weeks before it has to ship, right? And so I wanted to talk about what it was like to work on decade-scale projects and some of the commonalities between these projects, even though they were all very different. But there were some common patterns that we identified, that came up over and over again, and so I tried to distill some of the experience that we've had in doing these projects to sort of characterize them, so that when you find yourself in a certain situation, maybe you're more likely to recognize it.
Yeah. So yeah, maybe can you go through a few? Well, you also said that you tried some others first, which I found kind of funny. So you can go whatever you want first.
Yeah. So I observed these like common characteristics and stages of the life cycle of a project, and I was sort of like casting about for a good metaphor, and I looked at some existing life cycle, like the Gartner hype cycle, right, which has been kicking around for almost 30 years now and has been applied to dozens of technologies, and that was something that seemed like, well, maybe that's a good metaphor for these projects, but then it turns out that that wasn't actually the best metaphor, and so I looked at a couple of others and concluded that no, I have to make my own. But it also has 5 steps, like the Gartner hype cycle, and like the 5 stages of grief, because apparently it's a rule.
So we're preparing for a consultancy management. Brian, on all this.
Exactly. I'm preparing for my next job as management consultant.
Yeah, exactly. 5 stages of grief, though, are did it take you long to move past that, or did you try really hard to apply that?
Well, the first couple of stages, like denial and anger, I was like, yeah, I recognize those from some of the projects that I worked on, but it wasn't really the thing. But so the model that I sort of came up with is that you start out with sort of this like irrational optimism. We're just going to do this. It's going to be easy. Yeah. And then reality sets in, and so there's that's kind of like going from denial to to depression or to anger. But then like what happens with big projects is there's this like long slow climb where you chip away at the problem little bit by little bit. Year, 2 year, 3 year, you're making progress. It feels like we're almost there. And you eventually get to the point, which I call the peak of complexity, which is you actually have a solution. That's the third one,
So the second is the climb. The first is the optimism.
The first is optimism. The second is like the trough of disillusionment. Right. And then the third is the peak of complexity, where you have a solution and you might be tempted, I should just ship that solution, which would be a disaster. And the reality is your first implementation, your first answer, your first design is going to be terrible. It's going to be the thing that is the proof of concept that shows that the problem can be solved, but it isn't necessarily the good solution to the problem.
Yeah.
And a lot of projects make the mistake of shipping their peak of complexity solution. And I mean, the great example of that in Java is serialization. That was a total peak of complexity solution. Another one that's like that, that Stuart alluded to in the Ask Me Anything session that we just did, is the security manager. That was also a peak of complexity solution. And
it's funny that they both have in common this kind of like unseen mechanisms that are smart. And then until they're not.
Right, trying to do something magical so that you don't have to think about it. And the problem with shipping a peak of complexity solution is you become a slave to the complexity, right? So, you ship serialization and then you're going to discover that it's incomplete, it's wrong, it has flaws, it has security holes. And so what are you going to do? You're going to patch those with more complexity. Because that's the only tool you have available once you've already shipped something. And so you will never get out of that cycle. You will just be a slave to the complexity. And so
again, serialization, that's what you're suffering through, right? You made a joke today, every feature you talk about, you have to come back to serialization.
Absolutely.
So is that what you're saying? Like, so this is the eternal price that you're paying in every new feature.
Right. Yeah, it's not like we paid the price and it was high, but we're done. It's an ongoing thing that it interacts with every new feature that we add to the platform. It constrains what features we can add. It's really terrible. So what happened recently in Project Valhalla, we had a peak of complexity solution, and thank God we didn't ship it. And as we looked into, well, why is this so complicated? Well, a lot of it was we were solving problems we didn't have to solve. Maybe they were problems that we picked up along the way and we thought, oh, well, we'll just throw this one in the bag too. How hard could that be?
Not guilty of that at all. Just be like, oh no, this looks about similar enough.
Yeah, right. We get 2 for the price of 1. Awesome, right?
Yeah. So you end up with 2 for the price of 3 then.
Yeah, or 10. and as we started to say, well, we don't need to solve this problem. We can take this little piece out. Oh, that means we can simplify this thing over here. And that means we can get rid of this other thing. And there was this cascade of simplification, which was, it was kind of amazing because by the time we were done, it was like, where did all the complexity go? It was just, we just had this mountain of complexity, and now we have a tractable, reasonable thing with 2 or 3 small-ish looking features. Of course, they're not smallish, but they,
the surface area.
But they're simple enough to understand what they do. That makes us realize, oh, thank God we didn't ship that monster that we had 2 years ago. And we knew the monster we had 2 years ago was unshippable. But it's easy to kind of convince yourself, well, maybe it's not as bad as it looks.
It's hard to look at your own kit and say, yes, it's not good.
Yeah, exactly. You can easily fall in love with your own complexity. So this life cycle of going from ridiculous optimism to, my God, this is impossible, to I solved it, but I could never ship it. And ideally to, wow, there was a small solution lurking in there all the time that I didn't see.
But that's 4.
Yeah, oh yeah. So the 5th one is what happens next, which is, what took you so long, buddy? Right?
You just tack that on to get to 5.
No. I tack that on because this is my life, right? That like you struggle to like simplify something, and then what people say is, well, that's so simple. What took you 10 years? I could have told you that 10 years ago. I did tell you that 10 years ago, right? Because very often, like the solution we end up at looks very much like a solution that we explored and then moved away from, but then learned more about and were able to refine our solution. And so, there's always the peanut gallery second guessing, that's part of the process.
Okay, so now we got the 5 cycles. So it's like, okay, let me try to, the optimism in the beginning, the despair, the climb to the peak of complexity, I think called the
virtuous collapse.
That's a nice phrase. And then what took you so long?
Yeah.
It's okay. I still think that one is technical, but okay, I'll give you that.
Yeah.
Right, so why don't we play a little game and try to pick some ongoing Java projects and place them?
Okay.
So you would think that every project that's finished, like let's say Jigsaw, which introduced modules, that's in the why took you so long phase at the end there. Is that true? Are there things that you feel like technically done, still didn't quite arrive there?
So I would say that people probably didn't say what took you so long about modules because they're too busy saying other things about modules, right?
Just the nicest thing.
One of the big challenges for the module system is it was solving not only the problem of application modularity, but it was solving the problem of defending the integrity of the of the JVM.
Yeah.
And as a result, when you're solving two problems at once, you're going to get a solution that's more complex. And a lot of people looked at the additional complexity and say, couldn't you have left out the second thing? I really wanted the first thing, and I don't care about the second thing.
Yeah.
And the reason people should care about about integrity and strong access control and strong encapsulation is it's been kind of this hidden enabler of why we've been able to move forward so fast in the last 6 years since we switched to the rapid cadence. Because modularity has allowed us to draw boundaries around JDK components that we can rely on, and therefore unpredicted interactions between things are much less.
Yeah. So I had another about Jigsaw just now, and I forgot it. Well, that happens. Yeah. Long day. But is it generally true to say that all the projects that are finished are kind of like in that last phase, or do you think there's still projects that are like on the paper done that you still have some ongoing? I mean, maybe serialization, we already talked about that. It's other things where you feel like, no, this is still rearing its head every now and then. It's coming back and again, not even necessarily in a negative way, where we all think nowadays, I think, if only we could go back in time and just shoot serialization behind the bar and be done with it. But other features where you think, no, they're good, they're pulling their weight, but they're still ongoing.
Yeah, I think that's actually the more common case, right? That we have things like Panama, for example, which is there's more that we want to do there, right? And so I wouldn't say it's done. We can we can move on. There's lots more that we want to do, and so sometimes we ship something when we feel like, well, we've got the core of it done. We can ship that, but we know we want to build more on top of it.
Yeah.
And so a lot of those projects are still in a to be continued, ongoing, but we don't necessarily call that by the name that the project name that we used when it was not yet a part of the JDK. Yeah. It's more like an improvement to the JDK, since now that thing is already part of the JDK.
So you'd say like the features, and that makes sense, right? Features are continuously being worked on. Collections, good example. They were probably the collections framework was Java 5, I want to guess.
Well, 1.2.
Oh my God! So I don't. That's before my time. That's why I don't know.
You young kids.
Yeah. So it led. David is sitting there, our editor, laughing. Anyway, so collections, apparently Java pre-ages, was done. But you will obviously see, like, there's still, tweaking, Stuart Marks tells about the concept. Because that makes sense, that's true for most things that end up in the JDK. But the project itself is kind of like wound down. Like they did it.
Exactly.
Okay, so let's pick current projects. So we have Valhalla, we have Leiden, we have Amber, we have Panama, which is in a funny limbo maybe because of the vector API. Where would you place those?
Yeah, so I think, with the exception of the vector API, I think Panama is in a pretty good place. The three components that we've released as part of Project Panama stack very neatly, which is there's the foreign memory API, which is usable even if you don't want to call foreign code, but you just want to access off-heap memory because you don't want the garbage collector moving things around on you and all of that. And then building on top of that is the foreign function API, so that if you want to call a native library, you can map the C types to the Java types, and you get back a method handle that you can then wrap a Java API around, and that's really nice. And then on top of that, there's a tool called JExtract, which allows you basically point it at a C header file, and it generates Java bindings for you for the structs and for the functions. So that's a pretty good start. There's more that we want to do there. The vector API is part of Project Panama, but it's sort of like off to the side, and that's been in this weird limbo of incubation for a long time. And the reason for that is we realized that the implementation of the vector API and the implementation of Valhalla have a lot of overlap, having to do with flattening objects and allocating them contiguously and all of that. And rather than commit to implementations that do almost similar but not quite the same thing, we thought it was reasonable to wait until we could rebase the vector API on top of Valhalla. So when JEP 401, which is the first Valhalla JEP, goes preview, then we will also be able to take the vector API to preview, ideally at the same time, but it might be one version later, depending on when in the cycle the Valhalla JEP hits.
But that's really good news. Just interesting news, because I didn't know that exactly. I knew that the Vector API depends on Valhalla, but what you're saying is it's not just amorphously Valhalla, it's specifically JEP 401. So that's the enabler for the Vector API to not become has as many previews, so it gets old enough to have a beer.
Yeah.
Okay, good. So that's interesting. Okay, that's good. That's good news. But that puts Panama pretty late in that, right?
Mm-hmm.
What about one thing I didn't mention, one project I didn't mention that really interesting is Babylon. Babylon, tries to improve Java's capabilities of transforming its own code, potentially pushing it off to the GPU, for example. That's like a big use case. Can you give us an idea what you think where that is? Is it still the youthful optimism? Because the talks I heard at JVMS last year were so amazing.
So I would say that it is climbing towards its peak of complexity.
Okay.
Which is to say that we have a pretty broad implementation. We can do a lot of the things that we want to do with it. We have proofs of concept, but when you talk to the architects, they say, "Yeah, I'm not sure it's ready."
Yeah.
And that's a sign that you haven't yet found the virtuous collapse.
Yeah.
And it is. It's a challenging API to use, especially even if you come from a traditional compilation background and you're used to viewing a program as an AST. The model of the program that Babylon gives you is a little harder to wrap your head around than an ordinary AST. And so we think that's a bit of a barrier to entry, and we're trying to figure out if there's a way to present the code model in a way that would be maybe more approachable to more developers. But we've had some nice experiments with Babylon for automatic differentiation. It's the basis of what's called the Heterogeneous Accelerator Toolkit, which is about writing code in Java that will run on GPUs. And there are a number of different ways that that we can use Babylon, but there's also a lot of open design questions about Babylon, about how do we integrate it into the Java programming experience, because it's great that you could write a write a function in Java and then say automatically differentiate that. But right now that's a runtime activity, where you call some reflective API, say, go get me the code model for this thing, now differentiate it, give me a method handle so that, that I can run that. But that means you're doing a bunch of work at runtime that maybe you'd rather do at build time. So how do we shift that to build time? Maybe we do that with the technology coming out of Project Leiden, or maybe we'll want to integrate that more strongly into the programming model using something like an annotation processor. And we're figuring that out. There's pros and cons, to both of those. Or similarly, let's say you're doing something like LINQ in C#. So let's say you've annotated a method of this looks like a Java method, but I'm gonna translate it to SQL using LINQ. And the the C# to SQL translator in .NET. There are certain functions you might call in your C# code where it's going to say, I'm not translating that to SQL. I don't know what the equivalent of that is. So you have to program in a restricted dialect of C# so that it can translate your query into SQL. And it will be the same for Java, right? So someone would have to write a specification for the the Java to SQL translator, and they'd have a Babylon processor for doing that conversion. And then, boy, wouldn't it be nice, even if you're not generating the query at build time, wouldn't it be nice if we could statically type check that your query would translate at runtime, so that you don't write a program, the compiler accepts it, and then it fails at runtime?
Yeah, okay, that's an interesting point. So you're saying there's room for a way, there's potential that in the solution that, yes, we will check at build time, but there's still a reason to maybe not pre-do all the work as much as we could, to just to give you the safety, but still defer the execution?
Well, yes, it may be that you want to defer execution because you don't necessarily know that you're going to need it.
Okay.
And it may be that there's also a bit of a concern about is this thing that you're writing actually Java? If really you're going to write this Java method, but no one's ever going to call it as a Java method, you're just going to use it as a template to translate it to some other computing model. That starts to blur the distinction of what's a Java program. And so our approach there is we want these things to be explicit to a point that nobody can be confused that this is, whether this is a Java program or not. And we haven't quite figured out what the right way to describe that in the programming model is. And so that, that's why I say Babylon is still climbing towards its peak of complexity, because we haven't answered all the questions that I think Babylon has to answer. And clearly there will be more complexity before we're able to start reducing it.
Yeah, okay, that makes sense. You have one thing in your talk that we didn't mention so far that I'm wondering where that applies here. You said that, or John Rose says that the architect's job is to find the primitive.
Find the primitive.
So we're in this 5 phases, 4+ phases. We're in those 5 phases. Like, where did you find the primitive? Like, how does it factor into that?
Yeah, so I think, if you're lucky, you figure it out early. Okay. Right, in the design iteration where you think that this is a primitive thing, and then you realize no, that's actually a consequence of this other thing, which is more primitive. So if you're lucky, you find that in the design iteration. If you're less lucky, you find that in the Virtuous Collapse, where you realize you built something that was built on the wrong thing, and then you have to rebase it onto the right thing, which is probably a big activity, in order to gain the to gain the benefits.
So it's fair to say that the sooner you find it, the lower the peak is. Yes. Okay, that makes sense.
Yeah, absolutely.
I would love to talk to you for so much longer. I didn't look at the time when we started, so I got maybe David, you can give us a sign about what we are. Okay, we got it.
Yeah, all right, we'll keep going.
An interesting one is where Amber fits on this, because I want to claim it doesn't.
Because
Amber is more like
it's an umbrella. Yeah, Amber is more of an umbrella for smaller individual things that aren't big enough to be their own project, but sort of have a common theme of these are productivity-oriented language features.
That's how you introduced it, but at the moment it's more like pattern matching, the pattern matching project.
The pattern matching arc is pretty big, and it sucked up a lot of the Amber cycles for sure. But we also had the chance to work on string templates and withdraw that.
That went great.
Yeah, well, it did, but that was like something that was closer to shipping our peak of complexity solution, right?
Yeah.
That I think we let it out a little bit too early, and we discovered, in the field rather than in the lab, that the design was flawed and we hadn't found the primitive yet.
Yeah. And it also reflects that this process, the preview process does work in the sense that people try it out. And so one thing I like about string templates is that people have been begging you, I think, since Java 8 to be able to write, if they have a function like a lambda to write to not say f apply 5 to add 10 to 5, but say like my function is f of 5. They really wanted to wait to f.5, just something that would get rid of the method name.
Yeah.
And that was my understanding, is like, no, that's not what Java does. And then string templates come around, they're like, because they're basically doing that, I was really worried that if that ships, even though I like the proposal, the people would be like, I now want f.5. Because now you've done it for something else. Give me this here.
The problem with f of 5 is an accidental one, which is that fields and methods are in different namespaces in Java, for good reason. So
I cannot follow you. Why is that fields
and methods are in different namespaces?
And that's the root cause for not being able to write f of 5.
Let's say f is in a field or a local variable. It's of type function from string to string or something like that. So that's a variable. It's in one namespace. So so the meaning of f as a variable is different from the meaning of f as a method.
Yeah.
And there may be a method called f. And so if we were to try to blur that distinction, then we would need rules for saying, well, if there's both a field and a method, and you're in this context, then pick this. But if you're in that context, you should pick that. And that kind of stuff bites you in the back, right? Yeah. It confuses people. It leads to subtle bugs, and so what we have now is more verbose, but it's explicit and it's very clear what's going on.
I was also under the impression that when I thought this through earlier, which is super tangential by the way, but anyway, that this is actually not it's not really well defined, because if I have a function, then f of 5 would mean f apply 5. But if I have an interface that extends function, makes a default implementation of apply that does nothing, but defines its own better apply method, then I can create a lambda that is either of this new type or of the function type. And if it is a function and I call on f5, I would guess it calls f apply. But if I have it as a sub function, then it should call the sub method, right?
Yeah.
Because that's the one I wrote as a len. That would be really weird.
That's the one that's the abstract method for that subtype.
Yeah, right. So that's
and so you change the static type from my function to function, and all of a sudden it calls a different method, right?
Exactly.
Yeah, you wouldn't want that.
Okay, but funnily enough, would that be similar with a string template processor? No, because that syntax is bound to the process method. But we're not going to get there anyway.
Well, and the direction that we're moving on string templates is that the processors are going away.
Yes.
And
so very much to people's delight.
Yeah.
The thing that makes things short are going away.
Yeah.
So yeah, I gotta say that I'm really curious to see where that goes, because I understand the reasoning to not have a default injection attacky string concatenation, but I still would like to see something else than string template.join or whatever.
Yeah, and that's probably what it will end up, right? It's not that we don't want to make things easier. We want things that are potentially confusing to be explicit.
Yeah.
And so there's a middle ground of how many characters do you have to type, and the answer is not 0, but ideally it's not 100 either.
Yeah, so I really think that the string template has to land in a space where they must be more comfortable than string concatenation, because the whole goal was we're going to give you something that you are more likely to use than string concatenation because it's just more pleasurable to use, and it's more succinct, and it just more clearly expresses what you want to say, but it can also be safe if you pick the right processor.
Right.
And if the answer is no, actually templating is more complicated to type and more complicated to do, but it will be safer, then that is a much harder thing to sell. Also because those solutions also kind of already exist, right? I can already do the SQL prepared statement, song and dance, if I want to be super safe.
Yeah.
Okay. Amber. So Amber, did you say doesn't really fit on that?
Right. I mean, there are individual projects within Amber that might fit onto that. But as you mentioned, pattern matching is this sort of multi-JEP story arc. Kind of like multiple seasons of a science fiction show. Each of those is an incremental chunk, that we're building on top of the things that we've done previously. So it's a little bit of a different game.
Okay, I like that you said science fiction, not fantasy. Okay, thank you very much for being here, Brian. That was great. As with all the other guests, I could just keep talking for hours and hours. I'm not sure whether the audience could listen for hours and hours. And also, I know that you don't have hours and hours. It's at this point Thursday evening, so
it's pretty zonked.
Everybody's getting ready to have the last evening and night here, and then we're gonna have another half Devoxx tomorrow, and then we're gonna go home. Thank you very much, Brian. I hope to see you around.
Yeah, indeed.
And everybody, thank you for being here. This is the last of this series. I hope you enjoyed it. If you did, let us know. If you didn't, let us know what you didn't like. I hope the sound got better. They had some audio issues in the beginning there. But yeah, it was a pleasure. It was a pleasure to do this, to have all these great people here to talk. And so once again, thank you. And thank you for watching.
Thanks a lot. Bye. Cheers.